For problem number 17, it states that a 50-gram object connected to a spring with a force constant of 35 newtons per meter oscillates on a horizontal frictionless surface with an amplitude of 4 centimeters. Find A, the total energy of the system, and B, the speed of the object when the position is 1 centimeter. Then find C, the kinetic energy, and D, the potential energy when the position is 3 centimeters. So first thing that I did was draw a little diagram here with the spring and the mass, and I wrote down everything that we knew. So we know that the mass is 0.05 kilograms, the spring constant is 35 newtons per meter, and the amplitude is 0.04 meters. The first question to find the total energy is pretty straightforward. We know that the equation for total energy is 1/2 Ka squared, so you plug in the knowns and you get 0.028 joules. That's the total energy at any time when this is oscillating back and forth. The second one is a little more difficult. You have to find the speed of the object when the position is 1 centimeter. In order to solve for this, I use the position and velocity equations that we derived the other day. We know that the position at a given time t is going to be the amplitude times cosine of the angular frequency times time. And we know the position is going to be, 0.01 meters. We know the amplitude and cosine, but we don't know what w is. So in order to find the angular frequency, we first have to find the period. And we know the formula for that is 2 pi square root of m over k. Plug everything in, and you get the period is 0.237 seconds. So the period is 0.237 seconds. 1 over that is going to be 4.211 hertz, which is the frequency. And the angular frequency is just 2 pi times that, which is 26.46. So if we plug that into our equation, we know that at 1 centimeter, the time it takes to get to 1 centimeter is going to be 0.050 seconds. So we plug that in to find the velocity at that time. So we know that our velocity equation is negative AW sine WT. Again, plug everything in. Basically a lot of plug and chug in this problem. And you get that the velocity is going to be basically 1.03 meters per second. And then C, it asks for the kinetic energy when the position is 3 centimeters. Again, I'm using the position function, and we know the position is 0.03 meters. Plug everything else in, and we know at that time, the time is going to be 0.027 seconds. Plug that into the velocity function, again, same function, and we get that the velocity at 0.027 seconds is 0.693 meters per second. Plug that into your kinetic energy equation, which is 1/2 mv squared, and you get 0.012 joules of kinetic energy. And then the final question asks for the potential energy at that same moment. So we know that the total energy is going to be the sum of the kinetic and the potential energies. And we solve for the total energy right up here at part A. So we just subtract the kinetic energy from the total energy to get 0.016 joules, which is the potential energy when the ball and the mass is at 3 centimeters. So hope that helps.